Thank you to Surfshark VPN for sponsoring this video. This is the story of Air Canada Flight 190. In the early hours on the 10th of January 2008, an Air Canada Airbus A319 was making the trip from Victoria International Airport in British Columbia to Toronto International Airport in Ontario. At 6:33 a.m., Flight 190 was in contact with Vancouver Area Control as they climbed to flight level 350. Flight 190 was then transferred over to Seattle Area Control. They'd be the ones clearing Air Canada Flight 190 to their cruising altitude of 37,000 feet. At 6:45 a.m., they were cleared to climb to 37,000 feet. By 6:48 a.m., they had been climbing for a few minutes, and they were 9 nautical miles from the US-Canada border at 36,600 feet. Suddenly, the whole plane experienced a series of jolts. It felt like the plane had gone over a series of speed bumps at high speed. The plane then started to roll to the right. It wasn't much, just 5.6 degrees. But then it started to roll to the left. This roll was much more severe at 28 degrees of bank. The plane was supposed to be wings level, and no one in the cockpit was commanding these rolls. The captain, who was the pilot flying, decided to disengage the autopilot and to hand fly the plane. The captain struggled to level the plane. For 18 full seconds, he fought with the plane as it rolled from side to side, commanding full rudder and full aileron corrections in both directions multiple times. During all of this, the plane kept descending. By the time they were at 35,500 feet, Flight 190 seemed to be under control. They cautiously descended to 31,000 feet. They took stock of their situation. They had quite a few injured passengers. 3 passengers were injured quite seriously. Everything that had not been secured in the cabin was thrown around. In fact, during the upset, the cabin service trolleys were lifted off the floor and were slammed into the ceiling. Thankfully, they came crashing back down in the aisle and not on someone. The pilots at this point had 2 possible diversion airports available to them, Kelowna or Calgary. Calgary was further away, but they opted for Calgary as the terrain at Calgary was easier to work with, and it had better medical services. The pilots hand flew the A319 all the way to Calgary, not daring to turn on the autopilot, fearing another upset. At 7:29 a.m., Flight 190 landed at Calgary without any further incidents. Out of the 88 people on board, 8 people suffered minor injuries and 3 people suffered serious injuries, but everyone survived. Once the plane was on the ground, the engineers carried out what's known as a heavy turbulence inspection. The A319 had been through a lot, and they wanted to know if it had been damaged in any way. The flight data recorders had shown that the plane had experienced G-forces well in excess of the limits set by Airbus. But the airplane was fine, even though parts like the vertical stabilizer had experienced loads 129% its load limit. Now we get to why the plane experienced the upset in the first place. On the way back, the pilots assumed that there was something wrong with the autopilot, but they were wrong. In fact, the source of the problem wasn't even on the incident aircraft itself. The problem was 8.1 nautical miles out in front of Flight 190. It was a United Airlines 747. Flight 190 had flown through the wake turbulence of another plane. But what is wake turbulence? When an airplane flies through the air, it creates turbulence in its wake. Specifically, it creates 2 counter-rotating vortices behind the aircraft. Think of it as 2 mini tornadoes behind a plane. The bigger and heavier the plane, the stronger the wake turbulence. This happens because the pressure difference between the top of the wing and the bottom of the wing causes the airflow to twist into conical vortices that then descends downwards. As Air Canada Flight 190 made the climb from 35,000 feet to 37,000 feet, United Airlines Flight 896, a 747 that was making its way from Hong Kong to Chicago, was out in front of it. The 747 was at 37,000 feet and on a heading of 081 degrees, whereas Flight 190 was at 36,600 feet. At that point, it flew through the strong wake turbulence generated by the 747, which resulted in the upset. But here's the thing. Wake turbulence is nothing new. We've known about it since the 1950s. Agencies such as NASA has done a lot of research into the subject, and those results were codified into standards that all planes must follow. So why didn't those standards keep Flight 190 safe? During the incident, the aim of Vancouver and Seattle air traffic control was to keep the planes separated by 1,000 feet or 5 nautical miles. Air Canada Flight 190 and United 896 satisfied these conditions. In fact, they exceeded them. So, ATC was correct to clear Flight 190 up to 37,000 feet. But the wake turbulence of the 747 extended well past that 5 nautical mile mark. Both the FAA and NAV Canada Air Traffic Control Manual of Operations have rules on aircraft separation for wake turbulence avoidance. But the thing is, these were primarily meant for takeoffs, landings, and terminal procedures. The 5 nautical mile separation limit was not enough to keep a lighter aircraft safe behind a much heavier aircraft. From 2004 to 2008, the NRC, or the National Research Council of Canada, flew Falcon 20 and T-33 jets behind large planes like the Boeing 767 and the 747 to better understand the turbulence kicked up by them. They found that the much smaller jets experienced severe upsets at distances of 8 to 16 nautical miles behind the larger planes. In some cases, wake vortices could be found 20 nautical miles behind the larger aircraft. In one of these tests, a Falcon 20 that flew through wake turbulence went past 90 degrees of bank and had an engine flameout because the engine ingested a vortex core. The thing about upsets like these is that flying through wake turbulence can be a harrowing experience. It comes out of nowhere when you really don't expect it. In this case, ATC delayed Flight 190's climb clearance for 4 minutes so that there would be adequate separation. When the clearance finally did come, the pilots thought that there was enough space between them and the 747. So when the severe turbulence hit, the captain was startled, and he thought that it was a flight control issue, as he's never faced wake turbulence this strong before. Since he's working under the assumption that this is a flight control issue, he disengages the autopilot and tries to steady the plane with significant control inputs. But those inputs were just making things worse because the inputs were out of phase with what the plane was doing. In this case, the pilot was, quote, out of the loop. But it really wasn't his fault. At the start of the incident, the plane was rolling a bit. This was the autopilot trying to stabilize the plane against the onslaught of the turbulence created by the 747. But the automation doesn't tell the pilots, hey, I'm dealing with some bad wake turbulence right now. The pilot has no idea that the automation is fighting anything at all. The pilot sees that the aircraft is doing something that they don't expect it to. They're going to assume that there's something wrong with the automation and therefore will disengage the autopilot. When the pilot does do that, they're thrown headfirst into an emergency that they were not expecting. It's very hard to enter the loop when there's an emergency. The last thing I want to touch on is how history repeats itself. American Airlines Flight 587 and Air Canada Flight 190 are very similar. Both planes experienced wake turbulence. Both pilots responded in very much the same way, by commanding full rudder deflections. In the case of Flight 587, the pilot commanded and held the rudder deflection for a relatively long period of time, which stressed the vertical stabilizer enough to fail. That could have happened here as well. Quote, on both aircraft models, full allowable rudder deflections at high speeds can be achieved with relatively small pedal displacement and light control force. This characteristic, in combination with a pilot startled by sudden large changes in attitude, could result in excessive rudder control inputs. End quote. After the American Airlines incident, Airbus warned pilots about full rudder deflections during high-speed recoveries. In fact, as far as Airbus was concerned, you should only use the rudder during takeoffs, landings, and engine-out operations. Air Canada pilots were told about all of this during their initial type training, but it wasn't a dedicated subject during recurrent training. After the incident, Air Canada made changes to its training. They also amended the TCAS to display non-threat targets so that pilots can have more situational awareness. The Transportation Safety Board realized that current separation requirements were not effective for all possible scenarios. At the time the report was published, there were plans on entering discussions with other agencies to reduce encounters with wake turbulence. If you're a pilot, I'd love to hear how you're trained to deal with wake turbulence. But before you leave, let me tell you about our sponsor, Surfshark VPN. Now, I'm just going to come out and tell you what I personally use Surfshark VPN for. I download a lot of Flight Simulator because I keep breaking it. It's a massive sim, and Microsoft servers are super slow. So I just use Surfshark VPN to change my virtual location to New York. Since they think that I'm in a major world city, my Flight Sim 2020 downloads are much faster. Another thing I use Surfshark for is to get around geoblock sites. I do a ton of research for this channel, and sometimes the articles that I want won't be available where I live. Not a problem. With Surfshark, I can get past any restrictions that I may face on the internet. Lastly, I love going out for coffee, but coffee shop Wi-Fi isn't exactly what I'd call secure. Surfshark encrypts all the data from my phone, allowing me to browse safely no matter where I am. Check out Surfshark VPN at the link in the description and use code AIRCRASH to get a whopping 83% off and 3 months free. Thank you to Surfshark VPN for sponsoring this video. Thank you for watching this episode of Mini Air Crash Investigation. If you like the videos that I make, do consider liking and subscribing. It will really help the channel grow. I will catch you guys next time. Stay safe.